Hello guys, how are you? Welcome back. We are continuing with effects of force on shape and size. We are focusing on an elastic material which is a steel spring. So now we are given results of an experiment which were carried out. Before we carry out an experiment, we need to learn how to plot a graph, right? So here is a table of results. Here we have the force in Newton from 0 to 5, and then we have the length in centimeters, then the extension in centimeters, and then we are to A, fill in the blanks in the table, B, plot the extension versus force graph, C, calculate the gradient, G, then lastly we are to determine K, where K is 1 over G. So we start by A, filling in the blanks. Before we do that, we need to study our table of results. So here we have a force, so there is no force here. No force. Right? No force, therefore no extension. So no force, no extension, right? Therefore the spring has, or whatever elastic material is in its original length, which is the natural length, original length. We denote it by L naught is 5.0 centimeters. And remember this formula, L new length is equal to L naught plus extension. Then E can be determined from this. Not so can you go and go have a load case, have a force. I have spring sail get there. Has a sour get there, or when spring sail, some natural length in your soul. Length and all we see tell us logo shop can also let us have a so this is the original length. Length yes spring is a taula. So it's a hohiwa, it's a compressive, this is the natural length. So the first blank that we need to fill is this one. So what we have here, we have 5.3. This is 5.3 from 1 Newton force. So springs of that so gets real. The spring extends from 5 to 5.3. So what's the difference? 5.3 minus 5 is equal to 3. So here, okay, E is equal to 5.3 minus 5 is equal to 0.3. Let's just put a 0.3 here. So 0.3. Alright? Then we are now here. So what are we saying? We are saying with this load of 2 Newton, the spring extends by 0.7. So the length of the spring increases by 0.7. It increases from what length? From the original length. From the original length. So spring says all gets a 0.7. So gets a how gets a silver since the demo which exist. So what gets a hochakai? Go tswa go length ya spring house e tell us tswa kae go shopong kana se tse mo tafling kana se tshwarela mo se bele mo letsogong so sa se compressor sa se re. So it increases from this length, right? It increases from this length. So that is that is 5.0. Where do we start here? But we know that if we increase this by this, we get 5.7, right? But I just wanted us to use the formula. This is the formula. I think I have to write it here. L is equal to L naught plus E is equal to 5 plus 0.7. Let me put a 0.0 so it's 5.7. Then we are now here, Rehayan. So here what are we saying? We are saying to move from 5.0 to 6.0, we will have increased by our spring by how many centimeters? Right? So we need what? The extension, given the new length of 6. And we have to subtract L naught. L naught is 5.0. This is just 1.0, right? So spring sa rona so ke tsegile ka bokae? Ka 1 go tswa go 5 go go 6. But if you write 1 just like this, you are going to get it wrong. Why? Because your values has to be consistent. The calculated values in your table, they have to be consistent. Like here is 1 decimal place. All of them has to be in 1 decimal to 1 decimal place. So it's 1.0. I mean 1.0. 1.0. There's consistency. Everything to 1 decimal place. We call it consistency. Right? Then how about here? From 5 to 6.2. So even if you don't have this formula, from 5 to 6.2, can't you see that it's 1.2? You can use this formula, but I think it's quite clear. It's 1.2, right? 1.2. Then we are now here. What are we saying? We are saying from 5 we increase by 1.6. From 5 we increase by 1.6. 5 we get 1.6, guys. K 6.6, right? K 6.6. So if you want, you can say from 5 original length. You know that original length was 5. And what was the extension? Rocket springs at the Kabukai, Harazanian, low do gets like 5 Newton. Yeah, gets like 1.6. Okay, 1.6. Therefore, in Nabukai, in 6.6. That's it. 6.6. So this is how we do it. Okay? This is how we do it, guys. So the next thing that you need to do now is to plot the extension versus force graph. So let's go on and plot. Okay guys, here's our grid. Now we are at B. Plot the extension versus force graph. Right? Okay, the graph normally takes a minimum of 4 marks. 4 marks. I want us to show how to earn all these 4 marks. The first mark is what? Labeled axis with units. Labeled what? Axis with units. That's the first mark. So we are to plot the graph of extension versus force. Extension comes first. That means it's on the y-axis. Extension. Correctly labeled, remember. Extension in, this is in centimeters. Centimeters. And then force in what? Newton. Can just write F in what? Newtons. Having done that, you earn 1 mark. 1 mark. The second mark is the scale. The scale has to cover more than one more than 50%, I mean more than 50% of the grade, more than 50%, right? So where do we start? We are going to look at the values of extension. Let's start with extension. Our extension is from 0 to 1.6. So we can plot, we can think of it as from, our scale can be from 0 to 2.0 then. So let me see, 0 is here, 1, 2. It's less than 50%. So if 0 is here, let me try 1 here, 1 here, 2 here. Oh, it's good enough, right? So this will be 0.0, this 1.0, this is 2.0, so definitely this is 1.5, right? Then this is 0.5, right? So my scale will be measured on the y-axis from 0. This is my first plot, from 0 to 1.6. I don't know what 0.6 is, somewhere here. It's just above 1.5, which is okay. 1.6, 1.7, 1.8, 1.92. So 1.6 is actually here. So from here to 0, we see it's more than half. Actually, you can count the boxes, these big boxes. It's 1, 2, 3, 4, 5. So your plots should cover more than 2.5, which is 1, 2, 3. It's more than 2.5. That's okay. Now let's look at the x-axis. This is the x-axis. Where are the x-axis values? Here they are. These are the x-axis force. So my force is from 0 to 5. So from 0 to 5, that's okay. I can have a scale which is from 0 to 5. It's still okay. But remember, here I can't be writing 1.6 here. No, it's not allowed. It has to be in a way which is easy to read. So it's 0 to 5. If 0 is here, 1, 2, 3, 4, 5 will be here. Can it be better than this? If this is 0, 1, 2, 3, 4, this will be out. So let's try just one square. 0, 1, 2, 3, 4, 5. Let me count the boxes. 1, 2, 3, 4, 5, 6, 7, 8. So I have to cover at least 4. So where is the half? 1, 2, 3, 4. This is half of the grid on the x-axis. So this mark is very difficult to obtain, my friends. Let me tell you. Because they fail to do this. Okay, I want you to pay attention. So half ya go ha ke bokae? Ke 4 ka go dio tse ile di 8 again. 4, 5, 6, 7, 8. So you plot the time from the first plot to plot the overhead. So 0 haleha ma ke bona 5 yo tana. So 0 ka nna, 1 na, 2 na, 3 na, 4 na, 5 na ka itudile ha, which is okay. That's good. I'm going to get this mark 0, 1, 2, 3, 4, 5. This is 6, 5. You see? So I've got this mark because this is half, and here 0, 1. Okay, 1, 2, 3. I said the half is here, and 1.6 already. 1.6 means 0. So we are going to check this side and this side. So you get scale 50%, more than 50%, right? Scale, it has to be more than 50% or equal to 50%, and it has to be uniform. It has to be uniform. Mara to have 0 ale 1 ale ha re bona le 3 wa romola ka ba ira yalo. Okay, so that's it. So the scale is okay. We have 2 marks so far. The third mark plot is the plot. You have to plot correctly with what? A cross. With a cross. So this is the third mark. Let's pay a lot of attention. Good. So where do we start? 0, 0.0. Okay, the first plot, right? Good. The first plot. Let me change the color. Good. You change the color. Huh? The first plot is 0, 0, which is here. 0, 0. Good. The next plot is 1 and 0.3. On the x-axis you get 1, then 0.3. Okay, so sometimes you want to the values they increase by how much? Okay, let me check. From 0 to 0.5, 0, 0.1, 0.2, 0.3, 0.4, 0.5. Good. What is 0.1 each division? From 0, 0, 1, 2, 3, 4, 5. So what are 1 divided by 5 because ke batla go bona gore go ke bokae. I get 0.2. Here the smallest division is 0.2. So let me test it. 0, 0.0, 0.2, 0.4, 0.6, 0.8, 1.0. Yes, it's 0.2. So I'm not good to go. I'll be able to count. Nice. So 1. So it's 1 here. The first is 1. Good. So 0.1. I'm on the y-axis. 0.1, 0.2, 0.3. Good. 0.3. 0.3, right? Good. So third plot is 2 and 0.7. 2. I'm going to 2, then 0.7. I can just count from here because I now know it's 0.7. Or I can start from here just for control. 5, 0.5, 0.6, 0.7, 0.7. 2 is here. Good. 2 is here. See? So that plot is here with a cross. Good. Then the fourth one, 0, 1, 2. So the fourth one is 3 Newton and 1.0. This one is easy. It's easy. 3 and 1 is this one, right? So they meet here. Good. Now the next thing, what am I supposed to do? 4 newtons is this one and 1.2. This is 1. We increase by 0.1. 1, 1.1, 1.2. So from 1.2 I'm looking for 4, right? 1.2, where is 4? Is 4 is 4? 4 is here. 4 is here. This is where they meet, right? So it's here. Good. Now 5, the last one. 5 is with 1.6. 5 is with 1.6. 1.6. So 6 and 1.6. Let me find 1.6 here. This is 1.5. So we increase by 1. Each division is 0.1. So 1.5, 1.6. So 1.6 is this one. 1.6, 1.6. I'm looking for 5. This is 5. Good. So this is it. So that means I got this one, I got this one, and I got this one. So the plot I plotted correct using a cross, right? Using a cross, not a dot. No, we don't use a dot. Don't use a dot. Okay? So the last mark is the line of best fit. Is it plotted correctly? I mean, is it drawn correctly using a sharp pencil? A sharp pencil. Your line has to be smooth and thin. It shouldn't be thick. Okay? Should be thin and straight. Line of best fit. So let's do that. Let's do that. So I'm now trying to draw the line of best fit from here all the way. See? I'm trying to do my best. Line of best fit. This is not the line of best fit. This is not good. This is not good. This is not good. But I have to try to balance the points, okay? I think this is the best we can do. Isn't it? Let me leave it here. Good. Good. So this is our line of best fit. We did our best. Let me see. There are 2 points this side and 2 points, almost 2 points this side. Yeah, this is the line of, this is the best. This is the best line. This is the line of best fit. So, line of best fit. So, this is how you get all the 4 marks. So now we need to look at calculating G and 1 over K. I don't know, probably we have to end our video here and then start a new one because I don't want our videos to be long. So let's go to the next video. Thank you.